Welcome to Module 7, Confidence Intervals. This is one of those topics that sounds intimidating, but is actually very intuitive once you understand what a confidence interval is actually telling you. And it's essential for interpreting any statistical result in the veterinary literature. Let's demystify it. Confidence interval gives you a range of plausible values for the true population parameter, the thing you're trying to estimate. The 95% confidence interval is the most common, and here's the technically correct interpretation. If you repeated the study 100 times and calculated a CI each time, about 95 of those intervals would contain the true value. It does not mean there's a 95% chance the true value is in the specific interval. That's a common misconception. What it does tell you is how precise your estimate is. Wide intervals mean uncertainty. Narrow intervals mean precision. Calculating a CI for a risk ratio involves a few steps because we work on the log scale. This is because the RR is a ratio and its sampling distribution is skewed. We take the natural log of the RR, calculate the standard error, apply the 1.96 multiplier for 95% confidence, and then exponentiate the limits to get back to the original scale. The key interpretive rule: if the 95% confidence interval includes 1, the result is not statistically significant because 1 means no association. Always look at the confidence interval alongside the point estimate. An RR of 3.5 sounds impressive, but if the 95% CI runs from 1.2 to 10.4, that's a very wide range. The true effect could be anywhere from modest to enormous. Compare that to an RR of 3.5 with a CI of 2.8 to 4.3. That's a tight, precise estimate. Same point estimate, very different levels of certainty. This distinction matters enormously when you're deciding whether to change clinical practice based on a single study. Let's calculate the 95% confidence interval for our RR of 4 from the cattle data. Work through the steps on the formula slide, then check your answer on the next slide. Let's walk through each step. First, we take the natural log of 4, which is 1.386. Then we calculate the standard error using the formula. Plugging in our cell values gives us an SE of 0.339. We multiply 1.96 by 0.339 to get 0.664 and add and subtract that from 1.386 to get the confidence interval on the log scale, 0.722 to 2.050. Finally, we exponentiate both limits. E to the 0.722 is about 2.06, and e to the 2.05 is about 7.77. So our 95% confidence interval for the RR is 2.06 to 7.77. This interval does not include 1, confirming a statistically significant association. The true RR is likely somewhere between 2 and 8, a wide range reflecting our modest sample size.